Let's take a look at our first problem, which is number 4 from your class notes. Now, in this case, I'm actually going to solve the problem 3 different ways so that you can basically see how all of these things are interconnected. What I want you to concentrate on in this chapter, in fact in not only this section but the previous section, is how we use the derivatives to find the maximum and minimum of a function. So let's take a look at this first one. The demand for a given product is given by the equation P equals 45 minus 0.01 Q, where Q is the quantity and P is the price. Given the revenue function, I want you to find the revenue function of R based on the quantity and for R based on the price. And once you have that, I want you to determine at what quantity you'll expect the maximum revenue to occur and what price you would expect that maximum revenue to occur. So let's start with our demand equation, which I have again copied down for you here. I'm going to go ahead and solve this for Q so that I can have it expressed both in terms of P and in terms of Q. So first thing I do is I go ahead and I add 0.01 Q to both sides. When I do that, that cancels out on this side. Adding the 0.01 Q to the other side gives me P plus 0.01 Q on that side. I now will simply subtract P from both sides of my equation, which leaves me with this equation. And finally, to solve for Q, I will divide both sides of my equation by 0.01. Now frankly, dividing by 1 over 100 is just like multiplying both sides by 100 over 1. So frankly, what I really did was multiply both sides by 100, which left me with 4,500 minus 100 times P. Now, let's first find the revenue equation in terms of price. And there's no significance to why I picked price first. I just had to start somewhere. So, revenue based on price. Remember, we find our basic revenue by finding the price that we charge for each item, and we multiply by Q, the quantity we sell. Well, since I knew that Q was equal to 4,500 minus 100 P, I will simply substitute that in for my Q. Distributing my P through the parentheses gives me a revenue equation of 4,500 P minus 100 P squared. Now, what I'll do to find the point where this is a maximum is I will take the first derivative, and taking the first derivative, I'm left with 4,500 minus, pull the 2 down times the 100 is 200, subtracting 1 for my exponent, leaves me with 4,500 minus 200p. Now, let's go ahead and set that equal to 0 and solve for p. First thing again is I will add 200p to both sides of my equation. On the left, I'll have my 200p. On my right, these cancel and I'm left with 4,500. Finally, I divide both sides of my equation by 200, which leaves me a price of $22.50. Now, honestly, at this point, if I were doing a very thorough investigation and wanted to determine for certain that this was the maximum, I really should use either the first derivative test or second derivative test to ensure that this was indeed the maximum. Frankly, when we do the test, I don't want you to take that much time verifying what we already pretty much understand to be true. So I'm not going to perform that function here either, but I want you to realize in a real rigorous investigation, you probably should double check to make sure that this truly is a maximum. But what I'm simply going to do at this point is I'm going to go ahead and plug this price into my original revenue equation, which we had right here, you'll recall. Plugging in my $22.50 in this equation yields me 4,500 times that $22.50 minus 100 times that $22.50 squared. If you plug that into your calculator, you will find that you're going to make a maximum revenue on this product of $50,625. Now, that's the revenue equation based on price. Let's go ahead and do the same thing, but we'll find the revenue equation based on the quantity. Now, once again, remember that the revenue equation is always the quantity times the price. This time, however, I'm going to take my very original demand equation that I gave you to start with, which was solved in terms of P, and I will substitute that back in my revenue equation. So Q times P, I will substitute the 45 minus 0.01 Q, which again was the very original demand equation that I gave you. That gives me Q times that quantity. Let's go ahead and solve for that by multiplying through by Q, which gives me 45Q minus 0.01 times Q squared. And again, I'm looking for the maximum, and to do that, I'm going to take the first derivative, which will leave me with 45 minus 0.02 Q to the first power. And again, that's the simple power rule in this step to here. I took the 2 times my coefficient and subtracted 1 from my power. Now you want the point where it's maximum, so you set the first derivative equal to 0. In this case, I'm trying to solve for Q, but what I actually did first was add 0.02 Q to both sides of the equation. On the right, that just cancels out and leaves me with the 45, and 0 plus 0.02 Q, of course, is just 0.02 Q. So now basically what I did was divide by 2/100ths. But to be honest, what I really did again was dividing by 2/100ths is the same thing as multiplying by the reciprocal, which frankly is 50. So I merely multiplied both sides by 50, which of course canceled this, and 45 times 50 was my 2250. So this is the quantity that will maximize my revenue. Now, once again, by the way, to be sure, to make sure I was doing a really rigorous proof and examination of this, you really should, in the real world, take time to focus and make sure you do a first derivative test or a second derivative test to ensure that this truly is the maximum. Again, in the interest of time, especially on the examination, we're usually going to be skipping that step and just assuming that this is indeed the maximum. So let's go back to our original revenue based on quantity, which we found earlier, and I will go ahead and substitute this quantity into that revenue equation. If I've done it properly, the maximum revenue should just be the maximum revenue, no matter which way you work it out, and let's verify that it is. Substituting my 2,250 in for my quantity would give me 45 times that quantity of 2250 minus my 0.01 times that quantity of 2250 squared. And if you plug that directly into your calculator, you do indeed find that that's 50,625. Now, let's go ahead and solve it yet a third way. Remember, revenue is nothing but price times quantity. Now, we know what the quantity is. We just solved for it. The quantity that will result in the maximum profit is $22.50. Let's determine what the price is that you would be charging. Let's go back to that original demand equation, which was 45 minus 0.01 Q, and I'm going to substitute in my quantity of $22.50. And this will give me the price that I charge when I sell $22.50 of the item. Now remember, the revenue is simply equal to quantity times price. And if I sell $22.50 at $22.50 a piece, that still gives me the correct answer of $50,625. Now that's the maximum revenue. I've solved for it 3 different ways, and my hope at this point is that you see how all of these things are related, and it's just 3 different sides of the same coin, if you will. 3 different ways to arrive at the same correct solution.